Most people think of artificial intelligence in consumer tech as something you actively use. You type a prompt, tap a button, or ask a question, and the AI responds. That visible interaction gets the attention. But in 2026, the most important AI work in consumer devices is happening quietly in the background. Phones, laptops, wearables, and smart home devices are increasingly designed around background AI tasks. And this shift is reshaping how consumer tech is built, optimized, and marketed in the US. Background AI tasks refer to continuous or semi-continuous processes that run without direct user input. These include things like battery optimization, photo organization, speech enhancement, predictive text modeling, security monitoring, activity recognition, and contextual awareness. Individually, these tasks seem small. Collectively, they place constant demands on hardware, memory, and power management. Designing devices around this reality has become unavoidable. One reason background AI has taken center stage is user expectation. Consumers now expect devices to feel proactive rather than reactive. Phones anticipate which apps you'll open next. Cameras adjust settings automatically before you take a photo. Laptops manage performance based on your habits. None of this feels like an AI feature, but it relies on models running continuously behind the scenes. To meet these expectations without draining batteries or overheating devices, hardware must be designed specifically for background workloads. Energy efficiency is a major driver of this design shift. Background AI tasks need to run often, but they cannot consume large amounts of power. This has pushed manufacturers to include specialized low-power AI accelerators that handle small, frequent tasks efficiently. General-purpose CPUs and GPUs are poorly suited for this kind of work. By offloading background AI to dedicated hardware, devices can maintain responsiveness while preserving battery life. Thermal behavior is another critical factor. Background AI tasks generate heat over long periods rather than in short bursts. If devices are not designed to dissipate this heat efficiently, performance degrades and components wear out faster. Modern consumer tech increasingly prioritizes steady-state thermal management over peak performance. This is why devices feel cooler and quieter even as they do more in the background. Memory architecture has also evolved. Background AI relies heavily on fast access to small amounts of data. Designers are optimizing memory hierarchies to reduce latency and power draw for these tasks. This includes closer integration between memory and AI accelerators, smarter caching, and improved data movement efficiency. These changes are invisible to users but critical for reliable background operation. Software design reflects this shift as well. Operating systems are being restructured to schedule AI tasks intelligently, pause them when resources are constrained, and resume them when conditions improve. This orchestration requires tight coordination between hardware and software teams. Devices are no longer designed around what happens when you tap the screen, but around what happens when you are not touching it at all. Security and privacy considerations also favor background AI. On-device models can monitor for threats, detect anomalies, and protect data without sending information to the cloud. This reduces network dependency and lowers exposure risk. Designing devices to support continuous local AI processing makes these protections practical without compromising performance. Another reason background AI matters is consistency. Visible AI features may be used occasionally, but background tasks run all day. If they fail, behave unpredictably, or consume too many resources, users notice quickly. Reliability in these tasks shapes overall satisfaction more than flashy features. Tech firms have learned that a stable, quietly intelligent device builds more trust than one with impressive but unreliable AI tools. Product differentiation has also shifted. As headline AI features become commoditized, companies look for advantages in subtle improvements. Better background noise reduction, smarter battery management, and more accurate context awareness are harder to copy and more valuable over time. Designing around background AI allows companies to compete on experience rather than spectacle. This focus is also changing how success is measured internally. Instead of optimizing for benchmark scores or single-use scenarios, engineering teams are evaluating performance over days and weeks of continuous use. Metrics like sustained efficiency, thermal stability, and long-term battery health matter more than peak numbers. Background AI makes these metrics unavoidable. Importantly, this shift does not reduce user control. Instead, it changes the nature of control. Users no longer manage dozens of settings to fine-tune performance. Devices adapt automatically, learning preferences and adjusting behavior in real time. The intelligence is built into the system rather than exposed as a separate layer. The design emphasis on background AI also explains why many recent tech updates feel subtle rather than revolutionary. Devices do not always look different, but they feel smoother, more responsive, and more reliable over time. That improvement comes from countless background decisions made by AI models working continuously. In 2026, consumer tech is being designed less around moments of interaction and more around the hours in between. Background AI tasks have become the foundation of modern device behavior. They shape hardware architecture, power management, thermal design, and software strategy. The result is technology that feels smarter not because it talks more, but because it works better when you are not paying attention.